Hello and welcome. Today we're going to continue our discussion on factoring polynomials completely. First, I'd like to recall factoring the difference of squares. Now remember, if you can write this as two things to the second power being subtracted, then it is the difference of squares. For x to the 6th, I may rewrite it as x to the 3rd raised to the 2nd, and 9 I may rewrite as 3 to the 2nd. My bases are x to the 3rd and 3, so I add them and subtract them, and this is factored form. To the right, I may rewrite x to the 10th as x to the 5th to the 2nd power, minus 5 to the 2nd power. My two bases are x to the 5th and 5, so I add them and I subtract them. Down below to the left, I may take x to the 4th and rewrite it as x squared to the 2nd, minus 4 to the 2nd. My two bases are x squared and 4, so I add them and I subtract them. Now in this case, look at this second polynomial. That factor can be broken down again as it is the difference of squares as well. I may break that down into the factors of x plus 2 and x minus 2. And remember, this factor of x squared plus 4 remains on the front, and you cannot factor it since this is not the difference of squares. To the right, I may rewrite this as 4x to the 6th all squared minus 1 all squared. My bases of 4x to the 6th and 1 are going to be added for my first factor and subtracted for the second. Now in the first factor, that cannot be broken down because it is not the difference of squares. We are adding between the two terms. However, in the second factor, I may rewrite this as 2x to the 3rd all to the 2nd power minus 1 to the 2nd power. So I can take those two bases and add them, 2x to the 3rd plus 1, and subtract them, 2x to the 3rd minus 1. And again, look at all three of those pieces to make sure that none of them may be broken down any farther, and they cannot, so we are done. Now let's recall factoring trinomials. In order to factor a trinomial, you need 4 terms. So my goal is to split up this negative 10n into 2 new terms. In order to do that, I multiply my first and my last term. 3 times 8 is 24, and that number goes on top of my x. On the bottom, I write the coefficient of that middle term, which is a negative 10. On the left and the right, I need two numbers that multiply to positive 24 and add to negative 10. Those numbers are negative 6 and negative 4. So all I'm going to do is rewrite my negative 10 using those coefficients. So negative 6n minus 4n, I used these numbers to rewrite my negative 10. I still have the plus 8 on the end and the 3n squared in front. Now I split down the middle, take out the 3n that's in common, leaving me with an n minus 2. On the right, I take out a negative 4, leaving me with an n minus 2. Factoring out that n minus 2 that is in common, I am left within my second parentheses 3n minus 4. Remember to look at each of those individual parentheses to make sure that they may not be factored down any farther. And since they cannot, I am done. Now to the right, you might notice this is a little bit different, but not much. The only difference is that the n is now raised to the 4th power and to the 2nd power, instead of to the left, where it was raised to the 2nd and the 1st power. So all we are going to do is we are going to replace n squared with x. So I'm going to rewrite this as 3n squared. Now if I make this an n squared, I need to raise it to the 2nd power so that it's the same as what I started with above, minus 10n squared plus 8. I'm going to replace that n squared with an x. So I end up with 3x, and then I have this exponent on the outside, squared, minus 10, and where that n squared is, I put my x, plus 8. Now from here, this is familiar, I can factor this. I multiply my first and my last terms to get 24, negative 10 on the bottom, and the left and the right, I have negative 4 and negative 6. Rewriting my negative 10 with negative 6x minus 4x, I bring down my 3x squared in the front and the plus 8 in the back. Now I may split in half and factor by grouping. Take out my 3x from the left, and I'm left with x minus 2. From the right, I take out my negative 4, and I'm left with an x minus 2. Taking out that x minus 2 that's in common, I'm left with my second parentheses of 3x minus 4. Now make sure that this cannot be factored any farther. Since I cannot factor either of the parentheses down anymore, I am done. However, we must remember, we must replace the original variable. We started with n's and we ended with x's. These are two completely different polynomials. So what I'm going to do is undo that first step where I've replaced n squared with x. In order to undo that, I am going to replace my x's with the n squared. So instead of x, I have n squared minus 2 and 3n squared minus 4. Now again, look at each parentheses to see if you can factor farther. I may not factor that first piece because it is not the difference of squares, and I may not factor the second piece because it is not the difference of squares either. So, because of that, you are done. Remember to make sure that the variable you end with is the same as the variable you started with. The reason I did not stop here was because I did not end with the n's. Since I started with n's, I had to end with n's. So I was not done until I replaced them into my polynomial. Now on the top left, I'm going to factor using my diamond method again. Notice the relationship between your variables. You have n to the fourth and n squared. Because these go down by 2's, I can do the same process that I did on the last slide. I am going to take n squared and replace it with an x. So first, I'll rewrite my n to the fourth as n squared to the second power, plus 13n squared minus 6. Now anywhere there's an n squared, I'm going to replace it with an x. So I have 5n squared, or x, and this exponent of 2 stays on the outside, plus 13n squared, or x, minus 6. Now this is familiar. You have x to the second, x to the first, so you may factor by the diamond method. Multiply the first and the last coefficients to get negative 30, and on the bottom I have positive 13. Two numbers that multiply to negative 30 and add to positive 13 are going to be 15 and negative 2. Using these two numbers, I'm going to rewrite my positive 13. I have a positive 15x minus 2x. You still have that 5x squared in front and the minus 6 in back. Now we split down the middle, take out the 5x that's in common on the right, leaving you with x plus 3. And on the left, I take out a negative 2, and I'm left with x plus 3 in the second parentheses. Taking out that x plus 3, my second factor is 5x minus 2. Now notice, we started with n's in this top polynomial, but we ended with x's. So what I need to do is replace my n squared and x just like we did in the beginning. So everywhere I see an x now, I am going to put an n squared. N squared plus 3 and 5n squared minus 2. Looking at each of these individual parentheses, I see I cannot factor any farther, so I am done. On the right, I see this relationship again. I have n to the fourth and n squared. I am going to replace my n squared with x, and that will make it into the form that we know how to factor using the diamond method. So 3n squared to the second is the same as your n to the fourth, plus 17n squared plus 20. I'm going to replace that n squared with x, so instead of n squared, I have x to the second power, plus 17, and instead of n squared I have x plus 20. Multiply your first and last coefficients to get 60. And on the bottom of your diamond we have a 17, that middle coefficient of x. Two numbers that multiply to 60 and add to 17 are 12 and 5. So I'm going to rewrite my 17x with a positive 12x and a positive 5x. In the front we still have 3x squared, and in the back we still have plus 20. Factoring out the greatest common factor of 3x from the left, I'm left with x plus 4. And on the right I factor out a positive 5, leaving me with x plus 4. Factoring out the x plus 4 that's in common, my second parentheses is 3x plus 5. Now remember to check. We started with n's, but we ended with x's. So we need to replace our x's with the n's just as we did in the beginning. So in place of my x, I'm going to write an n squared. So I have n squared plus 4. And in place of my x in the second parentheses, I write n squared. So I have 3n squared plus 5. Neither of these parentheses may be factored any farther, so we are done. Go ahead and pause the video and try the next two on your own. For the first, you should have b squared plus 2 and another factor of 5b squared plus 4. And for the second on the right, you should have 3x squared with minus 5 with another factor of x squared minus 2. We are now going to factor trinomials with two variables. Since our trinomial has three terms, we are still going to use the diamond method. Multiply the coefficients of the first and the last terms. 1 times 12 is 12, and on the bottom I have a 7. My two numbers that multiply to 12 and add to 7 are 3 and 4. So I rewrite my middle coefficient as positive 3, but instead of just one variable I have uv and positive 4 uv. I still have the u squared in front and the plus 12v squared behind. Split this down the middle and take out the common factor. I take out a u, and I'm left with u plus 3v. On the right, I can take out a positive 4v, and I'm left with u plus 3v. Now I see u plus 3v repeated, so I factor that out. And I'm left with u plus 4 in my second parentheses. Go ahead and take a moment to pause the video and try the next and last one on your own. You should have broken down your middle coefficient into positive 5 and positive 1. Factoring out the greatest common factor, you should have been left with x plus y in one parentheses with x plus 5y in the second parentheses. Thank you so much for watching. We'll pick up here in our next video. I hope you enjoy the rest of your day.